Fitchies fans, it's Mrs. Fitch here. Hope you guys are having a wonderful day. Today we're going to talk about dividing rational expressions. So last week we were multiplying those rational expressions and simplifying those rational expressions. So this is just kind of that next little layer. So our learning target is still looking at those fundamental concepts of algebra. So we're going to continue working on our algebra skills. And we know we're going to be successful when we can multiply rational expressions, which we did last week, and we're going to do some more of that today. The new part, dividing rational expressions and simplifying those rational expressions, which is what we were doing last week, and we just need to continue doing those in order to be successful. So let's get started. So we are going to be dividing rational expressions. So the long definition of this is the quotient of two rational expressions is the product of the first expression and the multiplicative inverse or the reciprocal of the second. So let's put the brakes on. What does all of that mean? So let's just break it down piece by piece. So the quotient would be dividing. The quotient of two rational expressions. We know that rational expressions are, in other words, we can call them fractions. So we are going to be dividing two fractions. So how do we divide two fractions? Well, we find the product, multiply. So multiply the first expression. So we're going to multiply the first fraction and the multiplicative inverse or reciprocal. Multiplicative inverses are what you multiply by to get 1. Reciprocal, probably more familiar with the word reciprocal. Reciprocal is where we just take our numerator and our denominator and we flip them over. Our numerator becomes our denominator, and our denominator becomes our numerator, right, of the second. So in other words, the product of the first expression, we're going to take the first fraction and we're going to multiply it by the reciprocal of the second. So let's go through a little bit of some problems, some little problem strings. Start off with kind of a basic problem. So let's say we had 2/3 divided by 4/5. Two rational expressions. So do we have two fractions? Yes. Quotient, dividing. So we're just going to divide these two fractions. How do you divide two fractions? You do the product, or we multiply by, we're just going to put a dot right there in the middle for multiplying, the first expression. So our first expression was 2/3, because we're just going to read it like a book, left to right, by the multiplicative inverse or the reciprocal of the second. And the reciprocal is just swapping those numerators and denominators, so times 5/4. We know that when we multiply fractions, we multiply straight across. So we get 10/12. We can simplify that fraction down to 5/6. So in a minute, we're going to look at these with some polynomials, but let's look at something real quick. Like, why is this true? So let's, I don't know, we got 2, 3, 4, 5. Let's go 6/7. 6/7. So technically, that fraction, 6/7, is the same thing as 6 divided by 7. So hold on to that thought. So let's look at that 6/7 one more time. I can take that 6/7 and I want to try and see if I can write it a little bit differently. If I just look at my 6 on top, that's really the same thing as 6/1, right? And I want to figure out if there is a value that I can multiply that by to get back to 6/7. So if I multiply that by 1/7, if I multiply fractions, I multiply straight across. 6 times 1 is 6. 1 times 7 is 7. So if I wanted to, I could actually take 6/7 and I could rewrite it as 6 times 1/7, right? Following me? So now if I go back to our definition, 6 and 7 are rational numbers, right? 6 you could write as 6 over 1. 7 you can write as 7 over 1. So they're rational numbers. So if I want to find that quotient or the division of two rational numbers, it is the product of the first times the reciprocal of the second. So I just did that problem, didn't I? Look at that. So 6/7 is the same thing as 6 times 1/7, multiplying by the reciprocal. How fancy is that? Alright, let's throw in, spice it up a little bit and actually look at some polynomials. And our numbers are going to work the same way, right? In mathematics, it doesn't matter if it's just nice little easy whole numbers or little fractions, or if we throw some polynomials in there. So let's look at x squared minus 2x minus 8 over x squared minus 9. And we're going to divide that by the rational expression x minus 4 over x plus 3. So if we go back to last week when we were talking about dividing rational functions, the first thing we did was factor. We went through all of our separate polynomials and we factored them. Same thing when it comes to dividing. So let's go through and factor these. So I'm going to start off with my first rational expression. I got that quadratic up there, so I know that I'm going to end up with two factors to get to x squared, x and x. A times c gives me a negative 8, so since it's negative, I know I have to have a positive and a negative. And then I got to multiply to get negative 8 to where their sum is negative 2. So I'm going to go with a negative 4 and a positive 2. Taking the quick moment just to check it. If I multiply these together, I get the negative 8. If I find the sum of these two numbers, I get negative 2. So it appears that I factored it correctly. So now let's try the denominator. Again, I got a quadratic, so I'm going to give myself two factors. To get to x squared, x and x, a times c is a negative 9. So to get a negative, I know I have to have a positive and a negative. A times c is giving me negative 9, and my b term is not there, so my b is 0. So I know they have to cancel each other out, so I'm going to have 3 and 3. Or I know that it's a perfect square, and that's going to give me my 3 and 3. Positive 3 and negative 3. And I'm going to leave this division symbol here for a moment, and I'm going to factor that second rational expression, and it's already factored. I can't go any farther. So I got x minus 4 over x plus 3. When we were multiplying, after we had everything factored, we looked for those excluded values in our denominator, right? Because we know that our denominator can never equal 0. So I'm going to look for my excluded values now. And I'm going to list those. So I'm just going to kind of jump down here a little bit in the corner, right, and find my values that x cannot equal. So I'm looking at my denominator. So this is telling me that my x cannot be negative 3. This one's telling me that x cannot be 3. And this one's telling me that x cannot be negative 3, but I already have that one listed, so I don't need to list it again. So now I have everything factored. Now I can proceed, and I know that if I'm dividing rational expressions, I'm multiplying by the inverse. So I'm just going to write it now all as one fraction. So my first rational expression was x plus 2, x minus 4, and then the x plus 3, and then the x minus 3. Then I'm going to multiply by the reciprocal, so I'm just going to flip my numerator and denominator and have x plus 3 on top and x minus 4 on the bottom. So here's a little bit of an extra step that we have when it comes to from multiplying to the dividing is now we need to go back and look at our denominator again to make sure we have all of those excluded values. Because once we flipped to that, or once we did the reciprocal of that second expression, we ended up getting a new factor in our denominator. And this new factor in our denominator is telling us that x cannot equal a positive 4. So we have to make sure that we're listing all of those excluded values of everything that could possibly be in the denominator. And then now I'm going to look, so then the third step, well, I guess we got to add these. So the third step would have been multiplying by the reciprocal. The fourth step would have been those excluded values one more time, if there was any new ones, which there most likely will be. And then the last thing is that now we can cancel out our common factors. So if I look back at my problem, I'm losing my, there we go. What do I have in common? I got x minus 4, x minus 4, x plus 3, and x plus 3. So in my numerator, I'm left with x plus 2, and in my denominator, I'm left with x minus 3. And then I have those excluded values. Don't forget those guys. So I'm going to go back for a second, and I'm going to talk about why we have those numerators and denominators. Like technically on this one, we had to look at our numerator and our denominator for those excluded values. So if I actually go back, I can rewrite that original problem, x squared minus 2x minus 8 over x squared minus 9. Since I am dividing, I could write this as a fraction. So it would all be over that x minus 4 over x plus 3. So we know when it comes to fractions, our denominators can never be 0. So we're looking for those values that would make it 0. So if I just look at this fraction, right, that x equaling negative 3 is one excluded value. And like technically, if I'm just looking at this fraction, I mean, x could be 4, because if x was 4, I'd have 0 over, I don't know, let's say 3. And I could have 0 rotten apples in my bucket of 3 apples. But the problem is when I do that, then that ultimately tells me this whole entire thing is 3. Now, or 0, sorry. So now I'm dividing that original, or that first rational expression, I'm now dividing it by 0. And I can't divide it by 0. So we have to make sure that when we're looking for those excluded values, we're looking at both of these. So some people do it differently. Like I say in mathematics, everything is a personal preference. Some people, as soon as they get it all factored, they're looking at all of those values for the exclusions. Our x minus 3, our x plus 3, the x minus 4, and the x plus 3, right? Looking at all of those at this point. Some people like to write down just these two, kind of like how we just did it in this problem, and then multiply by the reciprocal, and then find that last one. Right? I guess I should have made it this way. Find all of those excluded values, and then after you multiply by the reciprocal, find that other one. So it's personal preference on the way in which you want to do it. Hopefully I didn't confuse you more. All right, let's go for one more problem. So let's go with x squared plus x over x squared minus 4 divided by x squared minus 1 over x squared plus 5x plus 6. So the first thing we're going to do is we're going to go through and we're going to factor everything. So I'm just going to start upper left. I got a quadratic, and then I know I'm going to have two factors, and I know I have a greatest common factor of x that I can factor out, and then that's going to leave me with x plus 1. Then when I look at that denominator, I see x squared minus 4, so I know it's the difference of perfect squares. So I got x plus 2 and x minus 2 divided by, looking at my numerator, x squared minus 1. Again, I have another perfect square, so I'm going to write that as x plus 1, x minus 1. And then my denominator of the second one, I got a quadratic. I know that I'm going to have two factors. I got x and x to get my x squared. I'm multiplying to get a positive 6. And this guy's telling me that I'm going to have a positive positive and not a negative negative. So I got a positive and a positive. I got to multiply to get to 6. And the sum has got to add up to 5. So that's going to tell me I'm going to have a 3 and a 2. I'm going to list my excluded values. And I'm just going to go through on this time. And I'm going to look at all of these. And I'm just going to do it all at one time before I actually multiply by the reciprocal. So this one tells me x cannot equal negative 2. This one's telling me that x cannot equal 2. And then I'm going to jump right up here to the numerator. I'm going to kind of do these little together just to save some time. This is telling me x cannot equal negative 1. This is telling me x cannot equal 1. So x cannot equal negative 1, x cannot equal 1. I'm running out of some room here, aren't I? And then when I look at my denominator, this is telling me x cannot equal negative 3. And this one's telling me that x cannot equal negative 2. So x cannot equal negative 3, and the negative 2 is already included. Sorry, I ran out of room. Now I'm going to multiply by the reciprocal. So I'm just going to write it as one big fraction. So I'm going to start off with my first rational expression of x plus 1 over x plus 2, x minus 2. And then now I'm going to bring my denominator up to the top. So x plus 3, x plus 2. And I'm going to take my numerator and bring that down to the bottom. X plus 1, x minus 1. I already took care of all of my excluded values, so then now I'm just going to cancel out those common factors. What do I have? X plus 1 and x plus 1, and x plus 2 and x plus 2. I think that's it. So what do I have on top? I have x times x plus 3. And then in the denominator, I have x minus 2 and x minus 1. I think I got them all. I got some problems for you guys to practice. You can shoot on over to the class website at bit.ly/FitchMath and check out a couple of those problems that are listed on there. I hope you guys continue to have a good day, and I'll talk to you later. Bye.